Finding domains and ranges from graphs. Recall from the previous section or previous video, domains are the x values, ranges the y values. And we're going to use a graph to help us determine this. Now remember that a graph, you read it as far as x values go, and the x values always go left and right. So we're going to start from the left because that's the negative side. It's also the smaller side. Numbers are smaller when they're negative. So we're going to go from smaller to larger, and that's left to right. When we do the range, we're going to do from bottom to top, the lowest y value to the highest y value. So here's a few examples. What I'm actually going to do with this first example is to demonstrate to you a mistake that people make. Too many people pay attention to where it crosses the x and the y axes. That doesn't make a difference. It has nothing to do with this. First off, when we have a line, we're going to assume that these lines are going forever. Don't put the arrows on the end. And in fact, I don't care where it's crossing the x and y axis. So I'm going to come down here. I'm going to redraw the line because I don't care where it's crossing the x and y axes. So when I do the domain, here's all I'm going to do. I'm going to imagine that if this line is going forever and ever to the left, I don't care about down, that's a different question, this is domain. I'm thinking left. How far left is it going to go? It's never ever going to stop. So what that means is going forever left to negative infinity. And I always use parentheses around negative infinity. Always do. And now, how far right will it go? Well, it's going to keep on going forever and ever and ever to the right. I don't care about up, I'm thinking right. Nothing's going to stop it. That's your domain. Now the range is probably a little bit easier to see because it looks like it's going down. Well, it is going down, but it's also going left. But with the range, we're going to go down first. So how far down does it go? Well, nothing stops it. And how far up does it go? Nothing's going to stop it. Negative infinity to positive infinity. Let's look at a slightly different one. On this one, once again, I'm going to say that these go on forever and ever. So let's look at the domain. Once again, don't pay much attention to the axis until now, until the range. The domain we want. If you were to extend this, how far left would it go? Nothing's going to stop it to the left. It's always going at a slight angle left. As it goes down, it's also going left. How far right will it go? Well, it's going at a slight angle. As it goes down, it's also going to the right. Nothing's going to stop it. Negative infinity to positive infinity. Now let's look at the range. Now for the range, I look at the graph as a whole. So when I see this whole graph, it's going down forever and ever and ever to negative infinity. That's downward. How far up is it going? Well, this is the highest point that it has. So let's label that point. 0, 10 is what that point is. Range is the y values. So what's the highest y value? Well, what's the highest y value in the y-axis? Well, what's the y value of this point? Well, that y value is 10. And it is touching that point, and it's a closed circle, so that point's included, or that number I should say, is included. The point's included, which means that the y value is included. So I'm going to use a bracket. Let's do a couple more. Now watch this one. We got the domain and the range to find. Now when I do domain, I'm doing left to right. So start the farthest left value. So let's label this point right here. What is that point? 1, 2, it's off. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like it's at negative 9, 0. Let's hope this one is also at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is at 9, 0. So I'm looking left to right. Farthest left x value to farthest right x value. So how far left? By the way, since we are looking at only the x values for the domain, I don't care about that y value or that y value. I only care about the x values. So it's going left to negative 9 and going right to positive 9. Since the circle is going through both those points, I'm going to include both of those points by using brackets. So the domain is negative 9, 9. Now the range, I'm going to go down to up. So how far down is it going? Looks like 0, negative 9. How far up is it going? Looks like 0, positive 9. Since I'm doing range, I'm doing y values, which means I don't care about these x's. Got that? I'm going to mark them out. So how far down is it going? Or what's the lowest y value? -9. How far up is it going? Or what's the highest y value? +9. Since the circle crosses there, those points are included, which means those y values are included. So I'm going to use brackets around both of them. On this one, I'm going to say that the graph is extended forever and ever. So let's do domain and range. Now if you notice in my directions, it says on the domain and range of the relations. These two are relations, they're not functions. Functions are special relations. These do not pass the vertical line test, so therefore they're not functions, they're just simple relations. So on this domain, we're going to go left first. How far left is this curve going to go? It looks like to me it's going to go forever and ever, so that's a negative infinity. How far right is it going? Well, this is the farthest right point that it goes to, and that point is 0, 0. So what's the x value of this point? It looks like 0 to me, and it's included in the graph, so I'm going to use the brackets to show inclusion. And that's the domain, left, right. Now, you got to use your imagination a little bit for the range. How far down is it going? Well, if you were to extend this, it's going to keep on going down forever and ever. Even though it's going left, it's still going down. So that's negative infinity, because it's never going to stop. And if you extend it, as it goes left, it's also going upwards forever and ever and ever. That's a positive infinity. I use parentheses to show not included, and that's what you're doing. So in my opinion, graphing is by far the easiest way to determine domains and ranges, for the most part. Consider this example. This one is broken up into pieces. We got the left side and the right side. We're going to assume these extend forever and ever, so I'm going to use the arrows on the end. These numbers right here, where it's crossing the x-axis, this first one right here is a -4, so I'm going to go ahead and make it a little bit bigger. This one on the right side is a +4, just so you can see as a reference. Now when we find the domain, we're going to read left to right. Now look at the left side. It goes forever to the left, no matter which endpoint you want to start with or which portion of the curve you want to start with. It goes forever and ever to the left. So we'll call that negative infinity. Now this portion right here, when you read left to right, the whole picture from left to right comes from negative infinity, and it goes only to -4. So since it does cross the x-axis at -4 is included, so we're going to use a bracket. Now you notice from -4 to 4, there's nothing graphed there. So that means is we're going to look at this right side separately. So we start from the left. Once again, from the left, it's coming from 4. It is crossing the x-axis at 4, so we're going to say that's included with a bracket. Then it goes forever and ever to the right, to positive infinity. So become a positive infinity. Always use parentheses around infinity. Now here's the thing. We don't want two separate graphs or two separate intervals. What we're going to do, we're going to connect them with the union symbol, the big old U. So now our domain is this whole notation right here with the union connecting the two portions of the domain as one single domain. So make sure you use the U, the big U, to connect the two different intervals. Now let's do the range right quickly. When we do the range, doesn't matter which side you look at or which portion of the curve you're looking at, they're both going down forever and ever, and they're both going up forever and ever. So they're both going down to negative infinity, and they're both going up to positive infinity. Now remember, we're reading from bottom to top, down to up. So they're forever going down to negative infinity and forever going up to positive infinity. And that's our range. So watch out for the ones that are broken up.